If I was given £1 for every time the difference of two squares turns up in a GCSE exam paper, I would be a rich man. And this question is one of those examples. 4 is a square, x squared is a square, 9 is a square, and we have the difference between those two squares. So this will split into two brackets, where each of the bracket terms will be the square roots, 2x and 2x, and the square root of 9, 3, and 3. And because we need to generate negative 9 here, one of these is a plus and one of these is a minus. Let's check the results. Yep, 4x squared, negative 9. But when you multiply two brackets, we've got to multiply the underneath as well to complete our eyebrows and smiles routine. What do these give us? Well, 3 multiplied by 2x is 6x, and this pair, negative 6x. So the x terms eliminate each other. There is no x term in this quadratic. This one does have an x term. Do you see the difference? Okay, that's factorised the numerator. Now let's have a look at the denominator. Now here I can recommend a little bit of cheating. It's almost 100% certain that one of these two factors will cancel with a factor on the bottom. So in a way, the factorisation of the quadratic here will contain one of these two terms. I don't know which one yet. I don't often recommend cheating, but this is knowledgeable cheating. So factorising this guy, yep, okay, 2x could be there. We could have a 3. I'd have to have an x here, and I'd have to have a 1 there. Now, because I want to generate positive 3 and I have a negative sign already, both of these must be negative. Does this work out? 2x squared, positive 3. This generates negative 3x, and this generates negative 2x. So yes, we're there without much thought. A little bit of skullduggery. And as promised, two of these terms indeed do cancel each other out, and we're left with the remaining term on the top, which is 2x plus 3, and the term on the bottom, x minus 1. And that is your answer.